Hey there! Have you ever wondered how we can describe the position of a point on a piece of paper or even in a city? How do we know exactly where something is, especially when there are many options around? Well, this is where the concept of coordinate geometry comes in. Coordinate geometry is all about finding the precise location of points on a plane. It uses numbers to represent positions, and those numbers are based on the Cartesian coordinate system developed by the famous French mathematician René Descartes. You can think of it as a way to translate geometric shapes into math, making everything much easier to understand. Let's break it down. We need two pieces of information to locate a point, its distance from two fixed, perpendicular lines. These lines form a grid on the plane, similar to a city map with streets running horizontally and vertically. The point's position is described by two coordinates, typically written as x, y. The x value tells us how far the point is from the vertical line, while the y value tells us how far it is from the horizontal one. To bring this to life, let's take a real-life example. Imagine you're trying to find a friend's house in a city grid. If you know the street number and the house number, you can pinpoint the exact location. For example, if I tell you that my friend's house is on the 2nd street with the number 5, you'll know exactly where to go. This is how we use coordinate pairs in everyday life. In the same way, we can describe positions in a classroom seating plan. If someone sits in the 3rd row and the 4th column, we can label that as 3, 4. By using this system, we can precisely know the location of any desk, just like plotting points on a graph. Now, let's talk about the Cartesian coordinate system. This system uses two perpendicular lines, one going horizontally called the x-axis and one going vertically called the y-axis. These two axes intersect at a point called the origin, marked as 0, 0, dot. Every point in this plane is described using an ordered pair of numbers x, y, where x represents the horizontal position and y represents the vertical position. Think of it like giving coordinates to a treasure on a map. This system helps us map out positions in the plane in an organized manner. So, where do we place the points? Well, here's where the positive and negative values come into play. The x-axis has positive values to the right of the origin and negative values to the left. Similarly, the y-axis has positive values above the origin and negative values below it. This is how we end up with 4 quadrants in the coordinate plane. The first quadrant has both positive x and y values. The second quadrant has a negative x value and a positive y value, and so on. Each quadrant helps us understand where our point lies in the plane based on its signs. Now that we understand the system, let's talk about how to plot points. To plot a point, start from the origin 0, 0. From there, you move horizontally to the x-coordinate and then vertically to the y-coordinate. If both numbers are positive, you move right and up. If they're negative, you move left and down. Let's take an example to plot the point 5, 2, start at the origin. Move 5 units to the right along the x-axis and 2 units up along the y-axis. You will find your point right there on the plane. Let's practice with another point 4, minus 3. Start from the origin. Move 4 units to the right along the x-axis and then 3 units down along the y-axis. You've now located the point 4, minus 3, which lies in the 4th quadrant, where the x is positive and y is negative. Notice how each point's position depends on its values and the direction we move on the axis. By plotting several points, we can form geometric shapes and study their properties, which is the core of coordinate geometry. To quickly recap, in this module, we've learned about the Cartesian coordinate system, how points are represented with ordered pairs x, y, and how we plot them on the plane. We saw how the axes are divided into quadrants and how the signs of the coordinates tell us the location of the point. This foundational knowledge will be crucial as we move on to more advanced topics like the distance formula and equations of lines. So, now you know how to plot points and describe their positions using coordinates. In the next video, we'll dive deeper into how to calculate distances between points using the distance formula. I hope you now have a clear understanding of how coordinate geometry works and why it's so important in geometry. See you in the next topic.